Do not miss any of our cool videos. Subscribe to our channel for latest updates. Click on the bell icon now.
Hi guys, now that we have a basic idea and understanding of how to work with the different sensors on the Nano 33 BLE from our previous videos, let's look at a simple machine learning application in this video where we recognize different gestures such as left to right and up down by using the data on the accelerometer sensor. So we'll show you how to build a small application where you control the state of the RGB LED on board the BLE33 Sense and change its color based on the gesture performed. So for example, we can turn it one color when moving it left to right, and we can turn it to a different color when moving it up down. Note that this is just a demo and it can be extended to various applications. Suppose you want to turn an appliance off by making a left to right gesture or turn it on by making an up down gesture. You can easily interface the BLE33 with relays to achieve this purpose. Now in this video, we won't get into the specifics of the machine learning model, its algorithm and syntax as such. For this, we will use a platform called EdgeImpulse, which abstracts all the low-level details of the model and its syntax. So here is a small preview before we get started with the application. So let's get started with EdgeImpulse. Head over to edgeimpulse.com and sign up for a new account. Enter your name, a username of your choice, your email ID. Note that you will be sent an activation link on this email ID, a password that is both easy to use and secure. Accept the terms and conditions and sign up for a new account. Once you sign up for a new account, you will be shown this page. So since we're looking to connect our Arduino Nano 33 BLE Sense board, select the first option, connect a fully supported development board. This page lists out the instructions on how to connect different development boards with your EdgeImpulse account. Do have a look at the other development boards as well. For this video, we will be looking at the Arduino Nano 33 BLE Sense board. So the very first thing we need is to install the EdgeImpulse CLI. Before installing EdgeImpulse CLI, there are a couple of requisites. You need to have both Python 3 and Node.js installed on your system. Do let us know if you have any difficulties with getting these two tools installed in the comment section below and we will help you out. Also, if you're running on Windows, when prompted, allow the Node.js installer to install additional Node.js tools as well. So once the above two tools are installed, we can proceed with the installation of the EdgeImpulse CLI. If you run into any difficulties when installing the EdgeImpulse CLI, there is a troubleshooting guide over here. So once the EdgeImpulse CLI is installed, we next need to download the Arduino CLI. Download the appropriate version based on your operating system. Next, let's connect our Arduino Nano 33 BLE Sense to our computer. Press the button twice to put your board in boot mode. Download the latest EdgeImpulse firmware that we will be flashing onto our Nano 33 BLE Sense. Let's extract the contents of both these folders that we downloaded. Copy the Arduino CLI to your EdgeImpulse firmware folder. Note that an alternative way to do this is to add the Arduino CLI to your environment path variable. Then you can run any of these three tools depending on your operating system. This should start downloading the EdgeImpulse firmware onto your Arduino Nano 33BLE board. Once downloaded, we can exit. Next, we can run the EdgeImpulse daemon. So open a command prompt. Know that if this is the first time that you are running the EdgeImpulse daemon, it will ask you for your EdgeImpulse email ID and password to log into your EdgeImpulse account. So once that's done, you can head over to your EdgeImpulse page and you get the message that your device is now connected. Now that our Arduino board is connected to our EdgeImpulse account, let's start with gathering the data that is required to build our model. So head over to the data acquisition section. Ensure that the device selected is Arduino. Enter the label for our data. So we'll primarily work with two different gestures. We'll start off with the up-down gesture and then work with the left to right gesture. So let's start off by collecting data for the up-down gesture. So give a label title up-down, select built-in accelerometer as a sensor, and leave the sample length and frequency at its default. Press the start sampling button, and once it starts, move your board in an up-down gesture. So you can see the pattern here recognized by the accelerometer. Now in order to build a model, we will require a lot more data. So we will have to collect around 20 to 30 samples. Similarly, let's collect data samples for the left-right gesture. And let's collect a couple of samples of our board in the idle position. Now if you want, you can add more gestures, but I would recommend to keep it to a maximum limit of 4 due to the resource constraints on your Arduino Nano board. As far as the data is concerned, I would recommend collecting at least 30 samples per gesture. You can also collect additional samples. The more samples you collect, the better your model will be. Now that we have collected a decent amount of data, so I hope all of you have collected at least 3 minutes of data for each of the gestures. If not, please collect sufficient data before proceeding. Next, let's head over to dashboard, scroll down and rebalance your data set. What this will do is it will split all the data that you have collected into a test set and a train set. This will enable us to test that our model which is built. Once done, head over to Impulse Design and click on Create Impulse. Currently the data that we have is a very raw data. So we need to add some processing blocks so that we can extract features from our raw data. So select the option to add a processing block, and EdgeImpulse gives you suggestions on which is the best processing block that can be used. So for this, it suggests the spectral analysis block because it is great for analyzing repetitive motion from accelerometers such as gestures. So add that block. Next, let us add a neural network Keras block and save your impulse. So in order to further configure these two blocks, you get the options under your impulse design. Head over to spectral features, and here you can see how the raw data has been converted to a frequency domain, and you have a spectral power graph as well. Click on generate features. Once our features are generated, we can go on to build our model. Also here you can see the separation between each of your features. So you have the left-right gestures cluster over here, and you have the up-down cluster over here. The better the distinction between the clusters, the easier it will be for the model to distinguish between our different gestures. So next, head over to the neural network classifier. You can leave the number of training cycles and learning rate at its default for now. The maximum confidence rating is the confidence required by the model to classify it as a gesture. So if the confidence rating is below this, it will classify it as uncertain. So let's leave the existing features and layers at its default and add an extra layer as 3, since we have 3 gestures that need to be detected. Next, let's start training the model. So once a model is fully trained, we can see that we have achieved a really great accuracy results since we have used only a very few gestures. Then it goes on to optimize your model for different platforms such as your Nano 33 BLE Sense. Here you can see the various accuracy metrics of your model. And below you have several other statistics of how your model will perform on device. For example, it takes about 1 millisecond for inferencing, and it also shows you the RAM and ROM usage. So let's test our model as well. So once done, you can see how the model performs and individual data points as well. And you get your overall accuracy details. Now that we've built and evaluated our model, let's look at how we can deploy it onto our Nano BLE Sense board. So first head over to deployment. Select the Arduino library. You can analyze the optimizations if you want to have a more detailed look at your model and the resources that it will consume. Once analyzed, you can build the model. So this will download a library which has examples based on the model you have built. So let's open our Arduino IDE. Note that if you have previously used any EdgeImpulse library, ensure you delete those so that it does not clash with the existing one. So here let's delete the previously used EdgeImpulse gesture recognition library. And let's import the new library that we just downloaded. So once the library is added, we should be able to use one of the examples from that library. So let's select the accelerometer continuous example. Press the button twice to set your BLE sense in boot mode. Select the appropriate COM port. Ensure that the board selected is the Arduino Nano 33 BLE and upload the program. Do not be alarmed if it takes a while. These programs take quite a bit of time to get compiled. Once uploaded, open your serial monitor. Ensure to change the COM port. And you can see it now prints the gestures made by the BLE33 sense. So you can see right now it's at idle. Make a left to right gesture and you can see it get updated. You can change it to up down and see it getting updated as well. So let's try to make it more interesting by implementing a small application based on these gestures. So what we'll do is there's an RGB LED on the BLE sense that we'll try to control. So let's initialize our LED pins. I'll show you how to work with two different colors since we have two gestures, left, right and up, down, and you can further extend it to 3 or 4. So let's initialize these as output pins. And you can tap into the predictions using this prediction variable. Let's upload a program. Ensure you put the board into boot mode. Note that this RGB LED is connected in a common anode configuration. So here we are turning the red LED on and the blue off. And here we are turning the blue LED on and the red off. So if you see a left-right motion, changes the color to blue. and an up-down gesture changes it to red. So I hope you had fun and learned something new from this video tutorial. Do let us know what similar applications you are working on or what videos you would like to see in the near future in the comment section below. Until then, happy tinkering.